The topic of this video is the acid-catalyzed alpha halogenation of ketones. In this reaction, a small amount of acid catalyst is used to replace one of the alpha protons of a ketone with halogen. There are two differences between this reaction and the base-promoted alpha halogenation of ketones. First, it is acid-catalyzed. Only a small amount of acid is needed to catalyze the reaction, and the acid is regenerated, meaning that it's not used up, and it is a true catalyst. The second difference is that only a single halogen will add, substituting for a proton at the alpha position, even if there are additional alpha protons available. This is due to the mechanism of the reaction. First, the acid catalyst catalyzes the keto-enol tautomerism to the enol form of the ketone. The mechanism of this step has been discussed previously. In the next step, the enol attacks the halogen. The cation intermediate that is formed is resonance stabilized. In the final step of the mechanism, this cationic intermediate is deprotonated to give the neutral final product. It is important to understand that the reaction stops here. No further alpha protons are replaced by halogens, even if they are available. To understand why this occurs, we have to look at the mechanism. The first step of this mechanism in the formation of the enol is protonation of the carbonyl oxygen. If this mechanism were to occur again and produce a dihalogenated ketone, this would require protonation of the monohalogenated ketone. This second equilibrium lies much further to the left. In other words, the monohalogenated ketone is less basic than the ketone. Or we can compare the conjugate acids of this step. The protonated ketone is more stable than the protonated monohalogenated ketone. This is due to the inductive effect. The halogen pulls electron density away from the carbonyl. This makes the oxygen less basic because the electrons, the lone pair electrons on the oxygen, are less available to accept the proton. Because this first step of the mechanism lies further to the left towards the reactants in the monohalogenated ketone, the reaction stops occurring after the first halogenation.